that happen? Hello again, and welcome back to another episode of Adding Game Sounds, where today we're going to be moving on with our music that we've been implementing into the 4th level of the 2D game kit in Unity. It's now time for us to look at how we can implement the second parameter, which is this one here, distance to goal. And as always, if you see any scripts in this video that you'd like to use yourself, or if you want to download the FMOD project I'll be using and the music within it, you can go to this page on my website, Scripts and Assets, on scottsgamesounds.com, and here you'll find links to scripts you can copy and paste, or even projects you can download under each video they were used in. So don't forget to check that out. But jumping straight into the video today, let's quickly remind ourselves of how our music works. So, in the music that we created in our, music creating video, which I'll link to you if you haven't seen, we split our music up into 4 sections, all of which just kind of loop the sections individually, but the section 4 works in a little bit of a unique way. So in section 4, there is a link to another event in a event reference instrument, and that event is being controlled by its own parameter called distance to goal. So you'll remember that depending on the value that distance to goal is set to, we'll hear one of these 8 separate sections. Now the plan for the day is to use a script to link that parameter to both the location of our player character as well as the location of the goal the player is trying to reach, which in the case of this level is this key here. And then using that distance, we can control the value of that parameter. So the closer the player gets to that goal, the lower the number will be on our distance to goal parameter. And don't forget, the lower the number, the higher the intensity our music will play at. So if I set the distance to goal parameter to 8, and then set the parameter to 1, you can hear the difference in intensity. And the idea is, as the event goes through each of these sections, they all sound a little bit more intense than the last. So the closer, as the player travels towards the goal, the music gets more intense and more intense to kind of shout and scream at the player that you're about to complete the level. Okay, so if you'll remember from the last episode, we successfully got our music to play back in our game. And as the player progresses through the level and triggers switches that they can find scattered around the level, the music will progress. So if we go back to our event, we start at the intro section, and then with each key or switch the player interacts with, the music will switch to section 1, section 1, section 2, section 3, section 4, and so on. If you'll remember, we created a music playing script and attached it to the background music player object, and it's this one here, FMOD music level 4 goal. And straight away you should notice something different about it. We've now got a public variable which is referencing the key object, which, as I mentioned earlier, is our goal that the player needs to reach. So let's quickly open up that script and take a look at the differences I've and you will be making to it. Now, as you can see, there's a few differences you might be able to notice straight away. Now, the bulk of our calculations are being done inside an if statement. And that if statement is checking to see if the progress level variable, which is a new variable that I've created, is ever set to 4. Now, this variable is a float, so it takes numbers, and you'll notice that its value is being set within the progress function. So its value is going to match whatever value the progress level variable is. The difference is this variable called progress level has a capital P. Now again, in case you didn't see the last video I put up, this variable is being set by the various switches around our level. So let me quickly find one for you. Let's start with the first one. That's nice and easy. Now the interact on trigger 2D script is going to call our script and our progress function and basically set a value for this variable here, progress level with a capital P. So when the player shoots this switch, this value or this variable will be set to 1. Then once the player moves across the level and shoots this switch up here, the value will be set to 2. So now whenever that happens, not only will this variable be given a number, but this variable will as well. So what does that mean? Well, the update function, as we know, is running every frame. So every frame that is running our game, we're making this check. We're checking to see if progress level is ever set to 4. The reason why we're looking for the number 4 is because that is the section in which we want to start calculating the distance between the player and the goal, and therefore setting the distance to goal parameter. We don't want to do it when this section of music's playing or this section of music is playing. And you'll remember back from the last episode. Again, let me quickly find the switch. I think it's this one here. Yeah, there we go. Is that it? Wait, no, that might be the wrong one. Oh, it's this one here. There we go. So when this switch is activated, again, our function is triggered, and the value 4 is sent into this variable here, which is then sent into this variable here. And that is, that's when, basically, whenever this switch is triggered, that's when we're going to hear, this section of music here. So that's why we're making that check with the if statement. We're basically waiting to see when the section we're after is playing. Cool. So once we're set to 4 and the player's in position, it's time to start working out the distance between them and the goal. And the way we're going to do that is by using this line of code here. First, we create another float variable, which is going to hold numbers in. Of course, we want to work out the distance, and we've called it distance. Then we're going to set our variable distance to match the value that becomes a result of this function here, which is also called distance. And this function is derived from the vector-free struct. So what the hell does that mean? Well, as we may or may not know, I suppose, in Unity, or in any game really, there's coordinates. You've got 3 different axes of coordinates, and therefore you've got 3 different numbers. You've got a number for the X, Y, and Z coordinates. Even though, we're in a 2D game, we still have all 3 axes. So the position of both the player and the goal is determined by 3... I can't even click on the player now. Here, let's do that. There we go. There we go. It's determined by 3 numbers. One number representing where they are on the X-axis, Y, and Z. So what we need to do is take the vector of our player's position as well as the vector of our goal, which if I can quickly find is there. There we go. It's this one here. And we need to work out the difference between the two. But luckily for us, Unity already has pre-programmed functions for working out this kind of stuff. One of them is being distance. So when you're trying to work out the distance between 2 points on a 3D graph in Unity, you can write vector3.distance, and then inside the function's brackets, so this bit here, in fact, let me get rid of that just so it looks a bit more clear. So inside these brackets, you need to give it 2 pieces of information. That information is obviously the transform components, the transform coordinates, or the position coordinates of each position. So in our case, the transform position coordinates of Ellen, and then the key. From there, it will work out the distance and feed that number into our variables. So the first point is Ellen's positional coordinates, and we can find them out by using this line of code here. So first we need the Ellen object, and we need a reference to that. Now there's multiple ways in Unity you can reference objects within Unity that you want to find. And actually, I'll link a video in the description for you, or on the top right corner if that's possible, to another video on YouTube that is a really good explanation of different methods you can use for pinpointing and finding different objects in your Unity scene. But the way we're going to do it is we're going to use one of the scripts that are already attached to Ellen, as it's been designed by the creators of the 2D game kit for this kind of thing, for locating Ellen. And that is one of the variables within the player character script attached to Ellen. So I'm going to quickly edit that script and take a look at it. Now the variable s_player instance is of the data type player character, which is a reference data type, which means using this variable, we can reference the player character class, i.e. this entire class we're looking at right now. If we scroll down to the awake function, we can see that's exactly what happens. So as soon as the game starts, a reference is stored within the s_player instance variable, and that reference is of this class it's declared in. It's also a static variable, which means that not only is the data within it shared between other instances of this variable, even though there's only one in this scene, it also means that we can access it from other scripts by simply writing down the name in our script of the class it was declared in, which is player character. Now this works because we only ever have one instance of the player character class in our game, which is attached to Ellen. The problem is, however, this variable is protected, basically meaning we can't reference it from other scripts. What we can do, however, is reference this variable underneath it, which is of the same data type and is public. And that's exactly what this variable is designed for. If we look to the right of it, we can see what's known as a property or sometimes known as a singleton. In the first pair of curly brackets, we have the keyword get, and this basically means that this variable can be read by other scripts. Then in the second pair of curly brackets, we see the keyword return followed by our original variable storing a reference to the player character class. This basically means that if we ever try to access this variable, we'll be fed the data stored within the s_player instance variable. And again, because it's static, it's only ever going to hold one piece of data. So again, that's this class. We can also then access it by writing the name of the class it was declared in, so player character. Now that might seem a little bit confusing, and that's because it kind of is. So let's quickly go back to the FMOD music level 4 script. Let's have a look at what we've actually written in the first part of our distance function, and let's break it down and talk about how it works for us to access our player's coordinates. So the first thing we do is write the name of the class we're interested in, which is player character, and then we write the name of the public static variable we want to access, which is player instance. So we're basically telling our function to search through the game's files and find this class. Once it's done that, find this variable. Now it's allowed to access this variable because it's a public variable, and we don't need to point our code to a specific game object because this variable is static, meaning that even if there were multiple copies of this variable, they're all going to point us to the same piece of data. So we don't need to reference a specific instance of this variable. So by pointing our script to the player instance variable, the player instance variable then points our script to the s_player instance variable, which, as we know, is storing a reference within the awake function once the game starts to this entire script, player character. And because there's only ever one instance of this script in our game attached to Ellen, we can use it to access the transform component, which is the next part of our line of code we wrote, and then from there, access the position coordinates, which is the vector that we're after. One final thing to note if you are trying to set this up yourself is that these two variables, and the class itself for that matter, were all declared within the GameKit2D namespace. So that means in order for us to access both the class and the variables within the class, we need to tell our script to use that namespace. So all you do for that is write at the top of your script using GameKit2D, and you'll then be able to access both the class and the variables, or the public variables, within it. Now hopefully I've explained that well enough so you can understand the gist of how that works, but if you want to learn more, again, the video I mentioned earlier about referencing objects in Unity explains singletons very clearly, so I'd recommend you check that out. Anyway, moving on, so now we've found a way to reference the location of our player, we now need to reference the location of the key, the goal we're after, which is what we put in the second section of this function. Now the reason why the first method worked, the singleton method worked for the player character, is because we know there's only ever going to be one player character in our game. There's only ever going to be one person playing the game, and therefore there's only ever going to be one Ellen object, one player character class, and one copy of each of these variables. However, with the key, there can potentially be multiple keys within a level, so we can't unfortunately access a script that has these singletons or these variables within them. Not that there is any, but even if we tried to set these up in our own script attaching to the key, it wouldn't work. So we need another way of accessing it. So because in theory there can be multiple keys within our level, we need to tell our code that we want to reference the location of this key specifically. Now the way we do that is with the public variable we looked at earlier. So if we click on the background music player and have a look at our FMOD music level 4 component, again we can see that public variable called goal is referencing the object, and the way you do that is by finding the object in your hierarchy tab, clicking on it, and then dragging it into the box next to the variable. If we quickly go back into our script again, you can see that this variable goal is of the game object data type and is public, which is why we're able to access it through the inspector. So now we have a reference to our object, but we can't feed that into our function because it will only accept the vector-free data type. So that's where this variable comes in. So as you can see, goal location is of the vector-free data type. So in the start function, which runs on the first frame, I'm setting the value of this variable to equal the object reference within the goal variable, to equal the position coordinates within the transform component attached to the game object that is referenced within the goal variable. So now goal location contains that vector, or those, if I quickly click on the object, contains these numbers here, the positional coordinates of the key. So then once we have those coordinates, we just need to feed it into our function. And there we go. So now every frame, we are going to have a value that's going to give us a distance between Ellen and our key. So now we've got that distance, what do we want to do with it? Well, let's go back into our event quickly and take a look at our parameter. So let's quickly remind ourselves what we're trying to achieve. We basically want to find the position in the game world when this section of our music is first triggered. We want to make sure that at that distance, the player is hearing the first part of this section, which will be when the parameter is set to 8. Then we want to spread out each mini section of section 4 evenly between that starting position Ellen's at and the end position, which is the location of the key. So how do we know when to tell our code to set this parameter to each value to spread them out evenly between the distance of Ellen's starting position and the key? Well, first things first, we need to find out how far Ellen is away from the key when section 4 first triggers. So what I've done is I've wrote the debug.log command and fed it our distance variable. So now when section 4 of our music first activates, we're going to be given a value in our console tab of Unity, giving us the distance between the player and the key, which will be the maximum amount of distance the player can be. Now, whilst technically the player could go further away, all the way back to the beginning of the level, we're going to treat this as the furthest distance away, simply because this is when we first hear section 4 start to play. Okay, so we're about to enter section 4 of the music, so let's step on this pressure pad and see what distance value we get. Okay, so there we go. So it's giving us a number of 32.5. So we can round that to around 32 or 33. And we can use that number as a starting point. So we know that that is the distance between Ellen and the key when we first hear section 4 of the music begin to play. So now all we need to do is some simple math. So if we take 32, the distance we just got, and divide it by the total amount of units that our little mini section can be split up into, which we know is 8, we get the number 4. So now we know that whenever the player travels a distance of 4, we want to switch between each mini section. And by doing that, we'll land on section 1 by the time the player gets to the key, which will be about less than 4. So now in our script, all we need to do is tell Unity, or tell FMOD, either one of them, to divide the value of our distance by 4. So for example, when the player is furthest away, we know that's a distance of 32. Well, if you divide that by 4 and feed that into our parameter, we get the value of 8, which is the exact value we want to set our event to. Then as the player starts moving closer to the key, say it gets about here roughly, well, let's say that that distance is now 28. Well, if you divide 28 by 4, you get 7. So there again, if we feed 7 into our parameter, we move along to the next section, which is what we want. So as you can see, this is nice and evenly going to spread each section apart based on the distance between the player and the key. So just like last time, we're going to use the set parameter by name command or function to start setting values to our parameter. Now our parameter is attached to the event that we have inside our event instance variable called music, which is of course our, well, not this one, our music event here, which we called level 4 music. So therefore we need to write the name of that variable followed by set parameter by name. We then need to write the name of the parameter in question, which was distance to goal, and then set its value. Now don't forget, this is going to be run every frame. So each frame we're going to be setting it a new value. And you can see that I've fed it the value of our distance and divided it by 4 like I described earlier. So now each frame that's run in the game, the distance between the player and the key is going to be checked. That value is then going to be taken, divided by 4, and then that value will be used to set our distance to goal parameter, triggering one of 8 mini sections within section 4 of our music. And that's pretty much all there is to the script. Now I know that was a lot and some of it was a bit confusing, so I hope you understood that. Please let me know if you didn't, and I'll try and I guess link you to more resources to explain it a bit better. But as always, feel free to copy this script, learn from it and use it how you wish. Again, you'll find links underneath this video to my website where you can copy it. But anyway, that's enough of talking about the script. Let's actually start our game up and let's have a listen to how this effect sounds within our game. Okay, here we are again, back right before we hear section 4 of the music play. Let's again stand under pressure play. And now let's have a listen to the music. So we can hear that first little mini section, which we heard last time. That's playing because we're at around 32 units away from the key. Now, if we move a little bit closer to the key, we hear the music change. If I go back, there we go, it changes back. So obviously where we're standing now, we're right on that threshold between where the parameter switches between 8 and 7. Now let's have a listen to see what happens when I jump down this hole. There we go, the music's changed even more. So now I'm just going to run around a bit, and I want you to just have a listen to how the music changes. Remember, we want it to basically intensify the closer we get to this key here. There we go, so the closer we get, the more intense it becomes, and then if we move away from it, it starts to go back down that, the parameter starts to go back up to 8, and we start to go back down the little mini sections of the event. So finally, let's head over to the key, let's collect it, and have a listen to what happens then. There we go, so we hear the last section of the music, and as we collect it, we switch back to the intro. Okay, and with that, that's pretty much everything you need to know in order to set up a similar system like this. If you have any questions, because I'm sure you will, that was, you know, a lot to take in, please let me know in the comments. I'll try my best to get back to you and explain them. And yeah, for the final time, if you want to copy these scripts, or the script I used in this video, just come to this page on my website, and the video will appear here in this little gap, and you should be able to copy the script from there. But yeah, if you have any recommendations for anything else you want to see from this channel, please let me know. I hope you're enjoying this little mini little mini series within a bigger series, talking about interactive music within this 2D game, and I hope you're finding it useful. Yeah, I think that's everything. So thanks very much for watching as always. I've been Henry Scott, and I'll see you in the next one.